Good morning, students. Now we are going to take HS second year mathematics class, and we are doing calculus, and it is first chapter, first part of the calculus, that is continuity and differentiability. That is chapter 5 we are doing, and we have done first lecture. In this we have done how to do the continuity. We have started exercise 5.1. Little we will revise what thing we have discussed in that class. In that class, we have said that one function y is equal to fx is continuous if limit of fx x tends to a is equal to fa. That is, a function y is equal to fx is continuous at x equal to a point is if it satisfies this condition, or this can be elaborately related as limit fx x tends to a minus, which is called LHL, is equal to limit fx x tends to a plus is equal to fa. Either we can do first one as the need of the question, or if we found that this is necessary, we will use that one. I have given one simple homework is with that one. I found so many of you have given the reply, so it is correct. I will not discuss that homework. We will continue our remaining questions of the exercise 5.1. We have done exercise 5.1 question number 5. Now we will do question number 6. Find all the point of discontinuity of f where f is defined by fx equal to twice x plus 3 if x less than equal to 2, and fx is twice x minus 3 if x greater than 2. So first I will write this question. It is exercise 5.1, question number 6. fx they have given two values. One value is twice x plus 3. Another value is twice x minus 3. Now students, here we need some prerequisite knowledge. It is what? That a polynomial function is always continuous. What I have said, that a polynomial function is always continuous. Polynomial is what? An algebraic function where power of variable is a whole number. That is 2x square plus 5x plus 5, or x to the power 100 plus y to the power 99 plus z to the power 10 plus 7. This is what? Polynomial. This type of polynomial, if we found, then it is always continuous, whatever be the range. Now see, for x less than 2, this is the value. This is polynomial. X greater than 2, twice x minus 3 is the value of fx. This is also polynomial. So what we found, at that 2, greater than 2 and less than 2, these two values, two ranges of x, fx is polynomial, so it is continuous. So we will write this one here. For x less than 2 and x greater than 2, fx is continuous. Why continuous? As it is polynomial function. For x less than 2, or to x less than equal to 2 is this. So less than 2, this is the fixed value. This is a polynomial. So of course we will mention here that as for less than 2 it is a polynomial. So for less than 2 it is continuous. For greater than 2, twice x minus 3, it is also a polynomial. So it is continuous. So greater than, less than, both have the polynomial value. So we cannot say that fx is discontinuous at the value x less than 2 or x greater than 2. x 2 থেকে ছোট, x 2 থেকে বড় হলে fx এর ভ্যালু কি হয়? একটা পলিনোমিয়াল। পলিনোমিয়াল সবসময় কন্টিনিউয়াস। তার জন্য কি বলতে পারি? যে x 2 থেকে ছোট বা x 2 থেকে বড় হলে ফাংশনটা কন্টিনিউয়াস, এখানে কোনো ডিসকন্টিনিউটি নেই। তো এটা আমাদের ইট ইজ গিভেন ইন আওয়ার কোয়েশ্চন দ্যাট ইউ হ্যাভ টু ফাইন্ড দ্য পয়েন্ট অফ ডিসকন্টিনিউটি। এখন 2 থেকে ছোট 2 থেকে বড়তে কোনো ডিসকন্টিনিউটি নেই, তার মানে উই হ্যাভ টু চেক আওয়ার এফএক্স ইজ কন্টিনিউয়াস অর নট এট এক্স ইকুয়াল টু 2। এক্স ইকুয়াল টু 2তে এফএক্সটা কন্টিনিউয়াস হবে কি না সেটা আমার এখন চেক করতে হবে। সো ফর yes, only one value left, that is 2 for x equal to 2. LHL, that is this part, this one we will consider now. Limit fx x tends to 2 minus. In this 2 minus means little less than 2. Less than 2 to this, for less than 2 of x, fx is this one. So we can write fx as here twice x plus 3. So this is the rule we know already. Now if we withdraw the limit, then if we withdraw this one, we have to replace x by 2. So 2 2s are 4, 4 plus 3, 7. So what is our LHL for x equal to 2? It is this 7 only. Now for RHL, limit fx x tends to 2 plus. In this case, what we get? 2 plus means greater than 2. So x greater than 2, our value of fx is twice x minus 3. Now, if we withdraw this limit, then x we have to replace by 2. 2 2s are 4, 4 minus 3, it is 1. So you see that LHL is 7, RHL is 1. And what about F2? F2 equal to 2, x equal to 2. So of course we will consider this one. 2 into 2 plus 3, that is 7. So we get LHL as 7, RHL as 1, F2 as 7. Therefore LHL not equal to RHL, not equal to F2. All are not equal. Though we are getting that LHL and F2 are equal, but still as RHL is not equal to, so we cannot say it is continuous. Therefore, they have said what? Find point of discontinuity. Therefore, point of discontinuity at x equal to 2. So at is equal to 2, our fx is discontinuous. So this is the answer of question number 2. Now we will do question number 7. So these are actually second type. They are asking, first one they ask about the continuity of a particular point. Now it is a little bit different. They are asking only the finding the discontinuous point. Our question number 7 is given as fx equal to modulus x plus 3 if x less than equal to minus 3 is equal to minus twice x if x greater than minus 3 less than 3, 6x plus 2 if x greater than equal to 3. So these are the three points we consider. Fx, three values. One is modulus x plus 3 for x less than equal to minus 3. Another is minus twice x if x greater than minus 3 less than 3. And 6x plus 2 if x greater than equal to 3. So this is our question and we have to find the point of discontinuity. Now students, you see that whole real number, total number systems is divided into three parts. One is what? Less than minus 3. another is minus 3 to plus 3, another is greater than 3. So we are getting three parts. Now for x less than minus 3, this is what? After all, a polynomial. Modulus x also can be treated as a polynomial part. So this is continuous. In between minus 3 and 3, this is continuous as it is polynomial. For greater than 3, this is also. So for that 3 part, it is continuous. So we have to check only what? Minus 3 and 3. So for x is equal to minus 3, at that point we will check LHM, that is limit fx x tends to minus 3 power minus. This means it is less than minus 3. This means x tends to minus 3, fx will be this one, modulus x. This is our values of fx. Now see, modulus will give two values. One value, modulus x can be written as x if x greater than 0, that is greater than equal to 0, that is x is if it is positive, and it gives minus x if x is less than 0. Here it is minus 3. So of course, if you put here, then it will give a plus 3. So I can write directly, if we want to withdraw this one, this limit part, then it will give what? Minus 3 modulus means 3 plus 3, that is 6 is our LHL for x is equal to minus 3. Now if we consider RHL, limit fx x tends to minus 3 plus, here minus 3 power plus means what? It is greater than minus 3. So of course we will consider this one greater than, so it will be limit x tends to minus 3, and this is what? Minus twice x. If we withdraw this limit, then your x will be replaced by minus 3, that is minus 2, and minus 3 gives plus 6. Now f minus 3, it will give similar thing. It is modulus minus 3 plus 3, so it is 6 only. So what we get? LHL 6 is equal to RHL 6 is equal to f minus 3. Therefore LHL is equal to RHL is equal to f minus 3. Therefore fx is continuous at x equal to minus 3. It is not discontinuous. So what we are getting? That less than minus 3, it is continuous. In between minus 3 to plus 3, continuous. Greater than 3, it is also continuous. Now we found extra thing, that at breaking point, that is less than minus 3, greater than minus 3, there are the two values of fx. So at this break point, minus 3, fx is continuous. Now we will check for another breaking point, that is for plus 3. Plus 3, same technique we will apply, and we will check that can we get these things. Now for x is equal to plus 3. If we put here plus 3, this one, then 3 minus little less than 3, this is minus twice x, so we will replace these things by, as it is greater than 3, so it is 3 minus means little less than 3, so minus twice x. So then if we put, this will give minus 2 into 3, that is minus 6. This is our LHL for x equal to plus 3. Now, if I take RHL, this, then our value of fx for x greater than 3, it is what? 6x plus 2. Now, if we put our values of x as 3, then we can withdraw the limit. 6 into 3 plus 2. So 6 3 are 18 plus 2 is 20. So LHL, RHL to not equal. Now if we take plus 3, it will be what we are getting for plus equal to 3, 6 into 3 plus 2, that is 20. So here LHL not equal to RHL. LHL, RHL both not are equal and not equal to 20 also. That is F3. So Fx is discontinuous at x equal to 3. So how many discontinuity we are finding? We found there are single point of discontinuity. It is what? At x equal to 3. So with that we end our question number 7. Now we will do question number 8. Question number 8, it is written that fx equal to modulus x by x if x greater not equal to 0 and equal to 0 if x equal to 0. So this is our question number 8. So now we are question number 8. If we write is fx is modulus x by x if x not equal to 0 and it is 0 if x equal to 0. We have to find what? Point of discontinuity. How to get this point of discontinuity? It is, we are now using for, it is also, you see that for x less than 0, greater than 0, it will be polynomial. So not to think about that, we have to consider only x equal to 0. At that point, we will check whether it is continuous or not. For x equal to 0, if we consider LHM, that is limit of fx, when x tends to 0 minus, that is little less than 0, then we will find limit. Here you see, when x is little less than 0, modulus x will turn into minus x. Why? Because for less than 0, modulus x turns into minus x. Now this is what? 1. After cancellation, we are getting this is as this cancellation 1, minus is there, so minus 1. If we withdraw the limit, then only minus 1 left. Now we will consider RHL limit fx x tends to 0 plus. 0 plus means little greater than 0. Limit x tends to 0. Here fx, when x little greater than 0, modulus x will turn into x. So then we cancel, it is only 1. Cancellation 1. Then if we draw the limit, this is 1. Remember, after cancellation we are removing the limit. Not before cancellation we are not limiting, because it is what? 0 by 0 form. Now f0, it is what? f0, when x equal to 0, it is 0. Therefore LHL not equal to RHL. So this, though all are not equal, minus 1, 1, 0. So what is the point of discontinuity? Therefore x equal to 0 is point of discontinuity. So this is our point of discontinuous we are getting, and yes, this is the answer. So with that we end our question number 8. Here point of discontinuity is of course at the breakpoint x equal to 0. Question number 9 is almost similar to 8. You will find fx is given as x by modulus x. Just numerator 1 is in the denominator. I expect you can do. If you have problem you can ask. We will skip question number 9 as it is similar with question number 8. Still if you have doubt you can ask. Now we will do question number 10. Question number 10, it is say that fx equal to x plus 1 if x greater than equal to 1, and fx equal to x square plus 1 if x less than 1. So let's write this one. Here also you have to find the point of discontinuity. So question number 10. fx has two values. One is x plus 1 if x greater than equal to 1, and x square plus 1 if x less than 1. Now students, again the same technique we will apply, that for greater than 1 fx is a polynomial function, so it is continuous. We have not to worry about this one. For less than 1 x square plus 1 it is also polynomial, so for greater than 1 less than 1 fx is continuous. Then where we have to check? We have to check only for x equal to 1. Now for x equal to 1, LHL, that is limit of fx, x tends to 1 minus, means little less than 1, x tends to 1. If it is less than 1, value is what? We can replace fx by x square plus 1. Now if we would draw the limit, then 1 square plus 1, that is 2 only. So left hand limit we are getting as 2. Right hand limit, that is limit of fx, x tends to 1 plus, that is little greater than 1. If it is greater than 1, then value of fx is x plus 1. So we are getting 1 plus 1, that is 2 only. So LHL RHL gives same value. For f1, if we put x equal to, automatically we will consider this line, so it is 1 plus 1, that is 2. Therefore LHL is equal to RHL is equal to f1. So fx is continuous. Continuous not only at x equal to 1, for every real number. Therefore there is no point of discontinuity. একটাও discontinuous point নেই. There is no point of discontinuity in the real number, in the function fx. So this is our question number 10. Now we will consider question number 11. Students, sometimes we found that similar type question. 11, if you go through, it is similar type, so I expect you will do. 12 also similar, 13 also similar. So 11, 12, 13 similar like that, so I expect you will do at home, and definitely you can do. Question number 14, I found here it is little different. Without giving the variable, here given the fixed number, that one I will show, which is little slight different from earlier on. So now from 10 to 14 when you have been. Still if you find any doubt in between this one, you can ask, and I will definitely show the result. Don't worry to ask about this one. Now question number 14. Here fx is given as three values. One is 3, another 4, another 5. 3 is when x is greater than equal to 0 and less than 1, and less than equal to 1, and 4 if it is greater than 1, less than 3, and it is what? Greater than equal to 3, less than equal to 10. Here actually total number system they have not said, they have given only this part 0 to 10 divided into 3 parts, 0 to 1 one part, 1 to 3 another part, and 3 to 10 another part. So two gap is there in the total interval 0 to 10. Here total number, real number they have not said. So here breakpoint is what? 1, another is 3. We'll check only at the point 1 and 3. For x is equal to 1, that is first breakpoint. 1 and less than 1 এ একটা ভ্যালু, greater than 1 এ another ভ্যালু, এইটার জন্যই চেক করব। কিন্তু 0 to 1 এটার মধ্যে it is what? A fixed function, that is a constant function. Constant function is polynomial, so it is continuous. 1 to 3 এই গ্যাপের মধ্যে this is what? 4 value. This is what? 4 is the value of fx, so it is what? Constant function, polynomial function, so it is continuous. In between 3 and 10 value is given 5, it is also continuous. So এখানেও এটা continuous, so এখানে you will not find any discontinuous point in this range, in this and in this gap. So where we can have possibility of getting only at the point 1 and 3. So for x equal to 1 we are checking, it is left hand limit, we are considering limit fx, x tends to 1 minus little less than 1. So this less than 1, when it is less than 1, value of fx is 3. So of course its value will be 3. Now if we consider the RHL, that is limit fx, x tends to 1 plus little less greater than 1. 1 থেকে অল্প বড়, so it is what? When x is greater than 1, it is the 4. So limit x tends to 1, it is 4, so it is 4. So what we are getting? LHL, RHL not equal. Now if we consider f1 equal to 1, then value of fx is what? 3. Therefore LHL not equal to RHL, not equal to f1. So at the point 1, we are getting LHL 3, RHL 4, f1 3. So they are not equal. So 1 is 1. Therefore x equal to 1 is point of discontinuous. So this is one part of the question we have done. Now we will do the second part. Second part means what? It is, we will check whether it is continuous at the point x equal to 3 or not. Similar this type we will check for this x equal to 3 also. So now we will move to x is equal to 3. So definitely little things will change. Now let's see what will be the values. If we consider x equal to 3, so LHL will be what? 3 minus little less than 3. Little less than, when x is little less than 3, value of fx is 4. Then this limit, if we withdraw, this value gives 4 only. So this is our left hand limit. If we take limit of fx, x tends to 3 plus, means little greater than 3. If it is little greater than 3, see x greater than equal to 3, greater than 3, so value of fx is 5. If we withdraw the limit, then value of this one RHL becomes 5. Now for x is equal to 3, if we consider x equal to 3, so you see that when x equal to 3, value of fx is 1, 5. So what we get? LHL not equal to RHL, though RHL and F3 is same, but we need what? All should be equal. So for that, what is the point of discontinuity? 3 is one of the point of discontinuity. So there are x equal to 1 and x equal to 3. Both are what? Point of discontinuity. At that two points, we are getting that fx is what? Discontinuous. So I think earlier we are getting one or like that. Now it is the question. This sum we are finding two point of discontinuity. Discontinuous at the 2 points. So dear students, with that I think you understood it nicely. If any doubt, you can ask me. Personal mobile number also you can ask. With that, we end our today's class.